Our program today takes us once more into a mysterious and fascinating world, the world of the insects of tropical Africa.
We shall talk about caterpillars, about wasps, and about praying mantises.
We shall barely skim the surface of an immense subject, for the insect fauna of Africa, and especially of the jungles and the rainforests in the equatorial belt, is as rich as any in the world.
Caterpillars have soft bodies and are good eating for a host of hungry enemies. Their main problem in life is survival, how to escape destruction.
Some of the African caterpillars attempt to solve this problem by the construction of ingenious communal shelters. They glue together the edges of a number of large, tough leaves so as to form a box of considerable strength and rigidity, in which they are safe from attack. When I said that they glue together the edges of the leaves, I wasn't using quite the right word. The edges of the leaves are held together by thousands of short lengths of silk secreted by the caterpillars. The shelter thus built gives security to the whole colony through the pupating stage and until their transformation is complete.
Silkworms, of course, are caterpillars, but many other caterpillars are also capable of secreting silk-like fibers, not unlike the threads which form a spider's web.
This tangle of silk-like threads, spread over and around part of a tree, is spun by another species of caterpillar than the one which builds shelters of leaves, but it has the same purpose: security. The colony is safe behind a tangle of threads which no bird would attempt to penetrate.
This seems a more permanent and more practical type of housing than the leaf boxes. The caterpillars can go out at night to feed and return to shelter for the dangerous daylight hours.
They continue to add to their protective defenses. The colony is clearly not the result of one single batch of eggs, since there are big and small caterpillars, obviously in different stages of growth, within the same colony. Some instinct must guide the young caterpillars, hatched at different times and perhaps in widely scattered locations, to the spot where the communal shelter is being built. There are not only bigger and smaller caterpillars in the colony, some have retired to a comparatively quiet corner to pupate. Clearly, before long, the whole shelter will be motionless and apparently asleep, like a legendary city under a magician's spell, awaiting resurgence to life. All caterpillars have a voracious appetite, and all caterpillars have 3 pairs of what are clearly legs at the front end of their bodies. In addition, most caterpillars have palps, pseudo-legs, fleshy and clumsy-looking, along their bodies and under what might be called their tails to support their weight and help in progression. This picture shows very well the mechanism of progression and the part played by legs and palps. But what about the loop caterpillar, which you saw at the beginning of this program and which has no palps?
And what about this?
Here, what I would call a progressive undulation of the body underparts takes the place of the action of the palps.
We put him on a sheet of glass so that you could see better this curious mechanism.
Caterpillars have solved their problem of survival in many other ways than by the building of communal shelters. Some species have grown clusters of sharp spines. Others have developed hard scales of metallic appearance. As a matter of fact, those of the specimen you are looking at could be taken to be made of pure silver. The color and glitter of these brilliant creatures defy description. The softest and most tasty of morsels becomes unpalatable if garnished with spines and razor-sharp scales. Other caterpillars have evolved another efficient system of protection. They are the hairy caterpillars. They have developed thick coatings of long hairs, which would surely tickle the throats of birds so unpleasantly that the birds would prefer not to tangle with them. And to make doubly sure, they have evolved a whole scale of ingenious deterrents. Hairs so sharp that they penetrate the skin of an attacker and break off, causing intolerable itching. And even mechanisms analogous to those of snakes, manufacturing a virulent, irritant poison carried in the tips of the hairs and causing intense pain upon the slightest contact.
We were ourselves the victims of the hairy caterpillar several times when photographing them, and we learned to handle them with great caution. Irritation of the skin and of the eyes could be produced even without direct contact, in spite of all the care we took.
Very few of the caterpillars which are protected by poisonous or irritating hairs or spines are dull-colored like this one. Evolution has generally caused those which are dangerous to an attacker to be highly visible, to flaunt the boldest patterns and the most gaudy colorings. This interesting fact of nature is known as warning coloration. It is also well known to the birds, and they leave alone those caterpillars with the most eye-arresting color patterns, knowing them to be unpalatable or poisonous. This loop caterpillar, for instance, is not likely to be attacked, even if its hairy defenses are not at once noticed. Its vivid pattern and coloring would effectively protect it. The waving of these paddle-like appendages is another defense mechanism, directed more, I think, against parasitic wasps than against birds. This warning coloration is such effective protection that a number of species of caterpillars which have no hairy covering, secrete no poison, and have no particular mechanism of defense have adopted it. The would-be attacker sees the bold pattern, the loud color. He says to himself, "Bad medicine," and leaves alone a dainty morsel which he would have found delicious and satisfying. One more degree in ingenuity. Markings which mimic the head of a snake, the eye of the snake boldly facing the intruder. And for good measure, this frightening pattern is repeated on every segment for the whole length of the caterpillar. And for good measure also, this one, which is one of the hawk moth caterpillars, also has a most effective weapon in a very hard, sharp spine characteristic of these species. Let us see now another example of the ways in which evolution has sought to ensure survival. This is the grub of one of the case moths, so called because their caterpillars construct out of bits of wood cemented together with silk, cylindrical shelters completely encasing and protecting their bodies. This one is not constructing its case. It doesn't normally work in daylight. The actual construction is only done at night. But I have opened the case to show you the occupant inside, and it is now trying to repair the damage I have done.
These caterpillars normally spend the day in their houses, suspended by a few strands of silk from some convenient branch. They can move freely, house and all. Only their head and the front part of their bodies normally emerge from the case, which they carry with them. There is a hole in the bottom of the case so that it remains clean and sanitary.
The case affords splendid protection against birds and also against another group of enemies, the parasitic wasps. These lay their eggs on caterpillars. Out of these eggs, tiny grubs hatch, which feed and fatten on the juices of the living caterpillar. When fully grown, these grubs spin their cocoons among the hairs of their unwilling host. This is a caterpillar heavily invested with the cocoons of parasites. You will see some of them fully developed, emerging from these cocoons. This unhappy caterpillar has fed with its own substance all the grubs which have spun these cocoons. You notice the cocoons opening as if they had hinged lids. From the world of the caterpillars, we have been led to the world of the wasps. Our first pictures of them will show you the extraordinary performance of one of the species which prey on caterpillars, paralyzing their victims by injecting their nerve centers with a powerful anesthetizing drug and walling up the helpless bodies to be devoured alive by the grubs hatched from their own eggs. I know this is a bit difficult to follow. I will try to explain as we go along. You are, of course, watching a female wasp digging a hole in sandy ground. Each time she emerges, she carries a load of sand and flies some good way off to dump it. No outward sign must betray that she has been digging here. Now she's about to leave. She carefully closes the entrance to the hole with a large pebble, as big as she can carry. She now proceeds to camouflage the entrance to the hole, filling it with sand and scattering the sand over the entrance until it would be impossible for anyone to detect the existence of the hole. The hole carefully hidden, she goes hunting. She has found what she is looking for, a caterpillar. Can you see her abdomen folded under the body of the caterpillar? She is injecting with her sting the paralyzing drug. She inspects her victim, and finding all as it should be, she flies off to return to the location of the hole. She locates the spot unerringly and proceeds to reopen the hole. Out comes the heavy pebble. She enters the hole for a last inspection and flies off again, back to where she left the paralyzed caterpillar. This is now partly dragged, partly carried to the hole. And it is now dragged inside. Seconds later, the wasp is out again. The heavy pebble is put into place to close the hole. And the entrance is again carefully concealed and camouflaged. At some stage, probably in the depths of the hole, the wasp lays an egg on or near the body of the caterpillar. This egg will hatch in due course into a grub, which will then feast on the living tissues of the caterpillar until grown and ready to pupate. The pupa, in turn, evolving into a wasp, which has to dig its way out of the hole before it can emerge to daylight. We had the luck, after several days of unsuccessful work, to see a wasp of another species actually attacking a caterpillar. Watch this time the action of the abdomen reaching out under the body of the victim, pressing the sting into its soft underparts. This is a much bigger, much heavier caterpillar than the one we had seen attacked before, and its transportation over any distance would be difficult. But this species of wasp has a quite different routine of instinctive behavior from the first one we had seen. The wasp makes no preparation. It is only after having found and successfully paralyzed the caterpillar that she proceeds to dig a hole in the nearest suitable spot. And she needn't take any particular care to conceal it. The whole operation will be over too fast to make any concealment necessary. The body is far too heavy to carry in flight, but the hole is not far away. No heavy pebble is used to close the entrance to the hole, but at this point the camouflaging is carried out with painstaking care. Does it occur to you that this is fantastic? That it is almost incredible that these primitive insects should carry out this formidable labor instinctively, blindly, for a progeny which they will never see? Try to construct in your mind some theory of how evolution and selection have brought this about, and you will feel hesitant about the most fundamental beliefs of science.
Luck is with us. We find still another wasp of still another species at work.
We soon confirm that each species has its fixed routine. This wasp does not fly out and drop each load of sand some distance away so as not to call attention to the hole. She drops each load just outside.
Judging from the amount of sand already accumulated, she has dug a pretty big hole.
She now closes up the entrance to the hole, taking very good care that the entrance is well concealed. She doesn't attempt, however, to camouflage the whole area disturbed by her digging. This would be a hopeless task. So any enemy may know that somewhere here she has dug a hole. But she relies on another cunning strategy. On the periphery of the accumulated pile of sand, she digs a number of shallow holes, each one looking like a real hole badly filled and badly concealed. to mislead and confuse the enemy. This took hours. When she finally left, we waited an hour for her to come back. We then gave up and left ourselves. When we returned, she surprised us. She had the charging of the entrance with utmost care and skill. With the false holes already cunningly dug around the sand pile, the chances of the real hole being discovered are small. You may ask why these extreme precautions? Against what enemy? The answer, other wasps. A number of species, instead of digging holes of their own and paralyzing their own victims, lie in wait while others are digging, watching for a chance to slip into the hole and to deposit their own eggs near the food supplies so laboriously procured by the legitimate owner.
On returning to our house, we see, actually on our doorstep, a very large blue wasp, intently watching a very large spider. I realize that the wasp has just stung the spider and is now waiting for the paralyzing drug to take its full effect.
Less than a minute later, the wasp takes hold of the now inert body of the spider and begins to drag it away. This is, of course, of utmost interest to us. Where is she going, dragging this heavy load? She takes it by a circuitous course to the wall of the house itself. And now she proceeds to climb, backwards, of course, up the wall of the house, hanging on to her enormous load. This can take her nowhere. There's no possible place where she could hope to hide her booty. She falls, not once, but twice. Then she gets hopelessly entangled in one of Michaela's flower beds. We try to move her to an easier spot. She's not the least bit disconcerted and starts out with undiminished energy, as if she knew exactly where she was going.
And she's going straight into another tangle of grass, and as difficult a place as she could find. She may not know where she is going, but I notice that no male wasp ever turns up to help. It is left to the females to do all the work.
Once more, I decide to help. I have taken the spider away from her, and she's frantic. So I pick her up now and put her back next to the spider.
We followed her and watched her until the evening, until the light failed us and filming had to stop. We never found out if she knew where she was going.
We find on the underside of a stone clusters of cells made of dried mud. Some are broken, but we see that each cell is lined with a kind of membrane made of silk. With the head of a match, we try to tear open this membrane in one of the cells, but it is too tough and doesn't tear. When we break through the membrane with a steel needle, we find in the cell a wasp. It was obviously about to break out of the cell as it is fully developed and in fact behaves like a wasp normally emerging from the pupa stage, straightening its wings and antennae. We are, and remain to this day, very much intrigued by these cells in irregular clusters with their parchment-like silken linings and the pebbles apparently embedded in the lead of each one. These cells are clearly made by mud dauber wasps, which use mud as a building material, but they are of a type we had never met before. We find a mud dauber wasp at the edge of a pool. She is actually filling up on water, taking a supply of water, which she will use to make mud. She finds some suitable soil and goes to work, mixing water and soil and probably some form of secretion of her own into a pellet of mud. Here's the mud cell under construction. She arrives carrying the pellet of mud and at once goes to work fashioning the pellet into part of the wall of the cell being built. She doesn't need a fresh supply of water. She picked up enough water on one trip to the pool to make up several loads of mud. The second load of mud is ready. The recent work is easily told from the work of previous days. The mud, still moist, is darker than a dry mud. This shot shows very clearly how she works, packing the mud into place with her front legs and mandibles. The cell is ready. We know what this final inspection means. On her next return, she carries a paralyzed caterpillar. To our surprise, she injects once more the paralyzing drug. Now she begins to push the caterpillar through the narrow entrance to the cell.
Now comes something which we could not see before, the insertion of the abdomen into the cell for the laying of the egg. When she has left, we look into the cell. The egg is suspended, held by a thread in a vertical position, on top of the bodies of two partially paralyzed caterpillars.
Here is a whole row of cells detached from a smooth wall, which makes them look as if a whole side had been neatly sliced off. In each are the bodies of caterpillars, usually two to a cell, and wasp grubs in various stages of growth. In the older cells, the grubs have fully consumed their supply of living meat. In older cells still are the pupae, which do not need feeding anymore. And here are some fully transformed, almost ready to break their way out of the cells. A wasp emerging from its pupa does not need the elaborate drying and blowing up of the wings which are needed by butterflies. You have seen the entire cycle of their coming into life, from the egg to the adult. To you, this face is not that of a stranger. The green praying mantis ranges over both Africa and Europe. You have seen its warning attitude intended to inspire fear. And it is fearsome indeed at close range, as another insect or small animal would see it. But compare with it now the appearance of one of our characteristic African mantises, in full face and in profile. You know that mantises are carnivorous and terrible killers, equipped with efficient instruments for the seizing, holding, and killing of their prey. In contrast, the pious attitude in repose. Savage killers as they may be, the praying mantises are easily tamed and learn to take drink or food from the hand. Here's another mantis, which we call the leaf mantis because it closely mimics a large leaf partly eaten by insects. This is one of the oddest. Nearly 8 inches long, incredibly emaciated, it seems to mimic one of the stick insects, which themselves mimic a twig of bamboo or of high grass. We have caught it in the act of laying eggs. And the egg-laying of this is a quite interesting process, the eggs being laid layer upon layer in a frothy secretion which hardens to form a protective capsule. This picture will give you a clearer idea of the extraordinary size of this creature and the utter disproportion of its body and its limbs. This is its head, which seems precariously swiveled at the end of an interminable neck. These are its wings, degenerate to the point of being merely vestigial and quite useless for flight. I leave you to judge if you have ever seen a more impractical-looking creature. Believe it or not, this also is one of our praying mantises. This one is the most strikingly designed, a killer like all mantises, but a killer bedecked in the most gorgeous garment. The little grasshopper is lucky to escape with his life. This mantis has one extraordinary feature. He appears to carry on his back a design which not only is unusually bold and striking, but is unsymmetrical, which would be an astonishing thing to find in an insect. But it isn't so. He has the same design on both his wings, symmetrically arranged, but in his attitude of repose, one wing covers the other. The little grasshopper escaped, but it isn't often that the terrible front legs, formidable weapons of attack, fail to hold their prey. And there is no mercy in the world of insects. Its gruesome meal at an end, the praying mantis proceeds to the most fastidious cleaning of the instruments of death. Mystifying creatures, these praying mantises, at once beautiful and grotesque and terrifying.